and you need to know the different classes that of supply, TNTX supply, right? So you try to learn of this, learn the different configuration and the limits of each class. Yeah. So you'll have to learn of this, right? And typically you'll see you want 15 volts to 30 volts, three phase supply with a ground neutral 4 wire. This is normally used for small commercial places like stores, workshop, restaurants, and stuff like that. And you'll normally see like a three transformers, four mounted transformers connected to that facility, right? And they have that have a limit of 500 amps, right? You got 150 to 3 volts 4 wire. Actually, it's supposed to be this supposed to be 230 400 volts actually. And I'm gonna change that one time because I want to put it wrong thing. It's supposed to be 230 400 volts. Yeah. Yeah, 230 400 volts, three phase, 4 wire. That is for more industrial kind of places like pump houses, sawmills, these kind of things, right? And same kind of thing, four mounted, 500 amps, right? Also, they were asking the exam if the customer exceeds the demand or the supply limit, what repercussions they will have. So this is the repercussions according to TNTech, right? So you'll have to also learn of this as well. Yeah. So everything in presentation up there is not fluff. It's basically important things that you'll have to learn. So this is what you ask in the exam as well. This is the various configurations that have, right? So also be aware of this and how to draw it as well, right? And how to label your line voltages and stuff, right? So this is our star connected supply with our delta secondary, right? And we center tap one of the delta windings, right? And that's how we're able to get three phase 230 volts. We could get 230 volts single phase, or we could get 115 volt single phase. Okay? But the center tap is like a neutral. Yeah. Cool. And this is like the power line. This is like the power line where we just similar like between your blue phase and neutral, you will get 200 volts. Yeah. And how you get that 200 volts? Because the potential between a phase to neutral will be 115 by root 3, you will get 200 volts. And that is only for your blue phase, right? The other phases, you'll get 115 volts, right? But for your blue phase, you'll get 200 volts, right? Like one configuration, you have your open delta as well. I didn't really see the ask question about open delta and stuff, but I think that might be a little too complex for you all. So most likely they will ask something based on this. And this is what I've seen in the past, right? You have your 6.6 kV side, and this is typically available in Port of Spain. If the question says that the customer is in Port of Spain, your high voltage cell will be 6.6 kV. It's within really specify, you can use your 12 kV, right? The configuration is easy, right? Open delta. Same thing as this are 230 400 volts. So you might also have to learn of this as well, because depending on what the question asks, they say the customer needs a 400 volt three phase supply, 230 volts single phase supply, whatever. You have to know how to draw it, right? Right. So metering is another thing that will come in the exam. This is just a theory about metering. So there's the different types of metering. You have socket type. So the socket type meter is like the meter outside the house, right? So basically, when the enter come, they come and put on the meter, slap it on, boop, right? And you reading how much current and power you're pulling from your house, right? I think you all would have saw that in the lab, right? You all should have a session on wiring, I guess. So you all would have saw the meter and the jaws and how it's clamping into the socket base, yeah? So it's socket type meters. You have a single phase, this is the one that you're using in your house, and you're limited to 200 amps in your house, right? So I see if some of you all have homes carrying probably your maximum main breaker in your house will carry 200 amps, right? Because that's the maximum that um, you could demand from utility for a residential house, right? Nice. The three phase now, it could go up to the 80 kVA, which is 200 amps per phase. So per phase, it could have 200 amps, right? But it could also have, for more higher voltages, you will have 201 amps to 500 amps. That's the maximum limit for CT metering, right? And then yeah, when you go up to high voltage metering, you have over 500 amps per phase, and then high voltage meter a customer switch, basically having their own switch gear and stuff like that in their facility to do their own switching, right? So most likely in the exam, you're going to be interchanging between socket type and CTs, right? And the two things will be interfacing with it. Socket type, as I said before, limited 200 amps. When you calculate the limits for a CT is the CT could go up to greater than 200 amps, but less than equal to 500 amps. Yeah, there is a limit for your CT. Yeah, so your lower limit will be 80 kVA and your upper limit will be 199 kVA. That's how much the CT could measure for this instance. Yeah, this is protection, basic theory that I put here for you all. I had a question asked about the definition of what a fuse. Explain what a fuse is. So you all make sure I learn of definition of a fuse. Yeah. Circuit breakers, I don't think you already asked you all about this, but just there for theory. Grounded asked you all about that question about this as well. Yeah. So this is the question here, right? This is what the question collectively is. All it is be changing is the KVA value. That's what I said. All it has is 230 volts, three phase, 230 volts single phase, and 115 volts single phase. Right? And all it has changed is demand value. Right? So this is the typical thing that you'll be using here, right? This is the Goshu and St. Augustine, right? St. Augustine is not in Porter speed, so we're using 12 kV. Yeah? You just say Porter speed, well, you put your 6.6 kV on your high voltage side. Okay? This is the diagram. They say eight of a suitable label circuit diagram. This is what they're going to do in the exam. Yeah? And label it like that. The phase voltages, and that kind of thing. Now we're going to be doing. Right? That's simple enough. You'll understand that, right? Yeah? Yes? No?
Yes, sir.
Right. So you see how I get this, right? Because they want that 230 volts, three phase, 230 volt single phase, and 115 volt single phase. Right. Nice. So here now, you see with the aid of a calculation, steady current and ampere and demand KVA limit for utility supply mentioned in part 1 and explain the repercussion if the limit exceeded. So the maximum KVA for the supply stated in part 1 is 50 to 350 kV. Right? And this is classified as commercial class B1 in the tier tech tariff. And this class also have a maximum current limit of 500 amps. Right? They give us the load demand to 72 kV. So if we calculate the load demand from the customer, it should be S, they are found out 72 kV, divided by root 3 times the voltage. So 72,000 root 3 by 230, you get 180 amps. Per phase, we join. Right? So, however, socket type metering is limited to 80 kV. So the limit for the socket metering, you prove that because number we say is 200 amps per phase. So how we get that? So it's really 80 kVA divided by root 3 and 230, 200 ampere phase. So the customer is within the supply range for the commercial class B1 and socket meter. And obviously the repercussions are highlighted in earlier slides I'll show you, right? So this is what you'll basically do for this type of question. And you'll always ask this, right? So make sure you know how to answer the question. Right? Everybody have any questions on this? You all understand this? Yeah? You're clear, right? Alright, so assuming that you all clear and also no questions. Right. So now they ask what meter and type of the utility provide the supermarket owner based on electrician calculate load demand. What meter consider must be made if the load demand increases by 50% in the future. So basically answer the question before. So that's going to say the utility will supply a socket type meter since the load demand is less than 200 amps. So we calculate the load demand before. It's 180 amps. Right? But if the load increases by 50% in the future, that will be 1.5 by 72 kV will give 108 kV. And then your new current demand will be 271 amps. Right? So he crossed the limit for socket type return. So we're going to do now. So you have to go to CT meter and you state your limits for CT meter. Right? Your limits are 201 amps to 500 amps, 81 kV to 991, 199 kV. Right? Which is within the limit for CT meter. And CT meter can measure these amps. That is greater than 200 but less than 500. Yeah? So this is the typical answer you'll write in the exam. Any questions on that? You all clear on that, right? Yes?
Yeah.
Nice. Good. Right. So the next question that you'll get now is you'll get something similar to this. You know, actually somebody gets shocked, somebody holds something, some kind of thing about getting shocked. And what they wanted to understand is this diagram here, basically that. Right? Is that if you have a broken ground or you don't have a high impedance part, no sorry, a low impedance part to ground, you will have a potential of getting shock, right? So this example is that let's say how the serviceman touch the live conductor at 12 kV and the ground neutral. So this is basically like walk on there, right? So you have the line there, right? 12 kV line. And this is your neutral, grounded. And he inside here, he touch the IE. Our piece, our person, right? So I remember he working at a height, right? So he have a lower impedance compared to the ground. So that's why he gets shocked, right? And then so that basically diagram could draw like this, right? The source will be a 12 kV source, the person, and then that's how you get shocked, right? And then this three necessary precautions will be taken to prevent such an incident from happening again. The first thing is to never send any job again. Right? I just joking. The first thing is related de-energize and isolate. So you must never work on energized circuits, right? Sometimes you have to, but in cases that you try your best to work on non-energized circuits. So obviously the first thing was to do de-energize the circuit and do the work, right? Also, the next thing you have to do is use proper insulation and proper PPE, right? Where it's insulated gloves, insulated tools, using hot sticks and stuff. You see that we using on the line, use them kind of things, right? And then use have dielectric boots and stuff, right? Obviously, you'll maintain a minimum clearance between your line and grounded neutrals or grounded conductors, because that will create a potential and you will get shock. Yeah. Any questions on us? Are you okay on us? Basically, it's here, right? Yeah, very cool.
Mm-hmm.
Yes, all right, right. So that is the event.